problem about Cauchy sequence. Let UN be a sequence of real numbers. We suppose that there exists a number mu belongs to the interval 0, 1, m less than 1, and a real k such that for every n belongs to n, we have un plus 1 minus un less than or equal k into mu to the power n. Prove that un is a Cauchy sequence. Use the equality up minus uq equal up minus up minus 1 plus up minus 1. We add up minus 1 and subtract up minus 1. Similarly for the other terms, plus and minus. Finally, plus uq plus 1 minus uq. We have up minus uq less than or equal up minus 1 plus up minus 1 minus up minus 2 plus etc. plus uq plus 1 minus uq. Now we can apply the inequality. We have up minus 1 less than or equal k to mu power n power p minus 1 plus k mu p minus 2 plus etc. k mu power q. We can take k mu power q as common factor since q is less than p. We have a mu to the power p minus 1 minus q plus mu to the power p minus 2 minus q plus etc. k mu power q is the common factor plus 1. We have the precedent term k mu to the power q minus 1 plus 1. K mu Q plus 1. So we have K mu power Q times mu is K into M into mu Q plus 1. The sum 1 plus mu plus mu square plus etc. is a geometric sequence of common ratio mu and number of terms equal P minus Q. So the geometric sequence, the sum is 1 minus mu, the common ratio, to the power number of terms, P minus Q, over 1 minus mu. Since mu is less than 1, so mu power P minus Q is less than 1, then less than or equal K mu power Q, the numerator is less than 1, less than K mu power Q over 1 minus mu. The ratio tends to 0 as Q tends to plus infinity. Mu is less than 1, so mu power Q tends to 0 as Q tends to plus infinity. So 0 over 1 minus mu is 0. Then up minus uq tends to 0 as q tends to plus infinity. So for every epsilon positive, there exists n0 belongs to n, such that if q is greater than n0, we have up minus uq is less than epsilon. Then for every epsilon positive, there exists n0 belongs to n, such that if q greater than n0, we have p greater than n0, since p is greater than q, and q greater than n0, up minus uq is less than epsilon. Therefore, the sequence un is a Cauchy sequence. This is the definition of Cauchy sequence. Another exercise about Cauchy sequence. Let UN be the sequence of real numbers defined by the first term u0 equal 1 and the relation between un and un plus 1, un plus 1 equal radical un square plus 1 over 2 power n. Prove that un plus 1 minus un is less than or equal Vn, where Vn is a sequence of real numbers to be determined. 2. Prove that Un is a Cauchy sequence. Now for Un plus 1 minus Un is radical Un square plus 1 over 2 power n minus Un. We can multiply by the conjugate and we obtain Un square plus 1 over 2 power n minus Un square. A minus b times a plus b, a square minus b square over radical Un square radical plus Un. We simplify by Un square is equal to 1 over 2 power n over radical plus Un. Now Un square plus 1 over 2n equal Un plus 1 is greater or equal to 1, and Un is greater or equal to 1, so the denominator is greater or equal to 2. Then 1 over 2n over the denominator is less than or equal to 1 over 2 power n times 2. Since the denominator is greater than 2, so the fraction is less than or equal 1 over 2 power n times 2. Is equal to 1 over 2 power n plus 1. Then Un plus 1 minus Un is less than or equal 1 over 2 power n plus 1 equal Vn. So Vn is 1 over 2 power n plus 1. Second question, prove that UN is a Cauchy sequence. We must prove that for every epsilon positive, for every P greater than Q, there exists N0 such that P greater than N0, Q greater than N0. We have UP minus UQ is less than epsilon. We know that UP minus UQ is UP minus UP minus 1 plus UP minus 1 minus UP minus 2 plus etc. plus UQ minus UQ minus UQ minus 1 plus UQ plus 1 minus UQ. For P greater than Q. From the first question, UP minus UP minus 1 is less than or equal 1 over 2 power P. Since UN plus 1 minus UN is less than or equal 1 over 2 power N plus 1 plus 1 over 2 power P minus 1 plus etc. plus 1 over 2 power Q plus 1 over 2 power Q plus 1. We can, for the sum, make 1 over 2 Q plus 1 as common factor, and we obtain 1 over 2 Q plus 1 divided by 1 over 2Q plus 1 is 1 plus Q plus 1 minus Q is 1 over 2 plus etc. plus 1 over 2 power Q plus 1 minus P. P 2 power P divided by 2 Q plus 1 is P minus Q minus 1. The sum is a geometric sequence of number of terms equal P minus Q. from 1 to p minus q minus 1 is p minus q, and common ratio equal 1 over 2. So the bracket is a sum of the geometric sequence is 1 minus half to the power p minus q over 1 minus half. So UP minus UQ less than or equal 1 over 2Q plus 1 into 1 minus half P minus Q over 1 minus half is equal half. So 2Q plus 1 over 2 is 1 over 2 power Q into 1 minus half to the power P minus Q is less than or equal to 1 over 2Q, since the bracket 1 minus half power P minus Q is less than 1, and 1 over 2 power Q tends to 0 as Q tends to plus infinity. So for every epsilon positive, there exists n0 belongs to n such that for q greater than n0 we have one over 2q tends to 0 and up minus uq is less than epsilon. Therefore, for every epsilon positive, there exists n0 belongs to n such that for p greater than q greater than n0, we have up minus uq is less than epsilon, and un is a Cauchy sequence. This is the definition of a Cauchy sequence. For every epsilon positive, there exists n0 belongs to n such that p greater than q greater than n0, we have up minus uq less than epsilon. Another problem, let un be a sequence of real numbers. Let Sn equal u1 plus u2 plus etc. plus un over n, with n strictly positive. 1. Suppose that un converges to 0. Part A, let epsilon strictly positive prove that there exists n0 belongs to n such that for n greater than n0, absolute of Sn is less than mn0 over n plus epsilon over 2, where m is a real constant. Part B deduce that Sn converges to 0. We have Un tends to 0. Let epsilon positive. There exists n0 belongs to n such that for n greater than n0 we have un less than epsilon over 2. For n greater than n0 we have n equal n0 plus 1, n equal n0 plus 2, etc. at n. For n greater than n0 we have un, so un0 plus 1 is less than epsilon over 2. Similarly, for un0 plus 2 and un. We have n minus n0 terms. From n0 plus 1 to n, we have n minus n0 term. So the sum u n0 plus 1 plus un is less than absolute un0 plus 1 plus etc. plus un, so is strictly less than an epsilon over 2 plus etc. plus epsilon over 2. We have n minus n0, the number of terms, into epsilon over 2 less than n epsilon over 2. N minus n0 is less than n. Sn is u1 plus u2 plus un0 plus etc. plus un over n, so absolute Sn is less than or equal absolute of the sum less than absolute u1 plus un0 plus un0 plus 1 plus un0 plus 2 plus etc. plus un over n. Now, by the given UN is bounded, so there exists M, a real M, strictly positive, such that UN is less than M. So Sn is less than U1, absolute U1 less than M, plus M, you have N0 terms, N0 times M, over N. Plus UN0 plus 1 plus etc. plus UN is less than N epsilon over 2 over N. So we have M N0 over N plus epsilon over 2. We can now deduce that Sn tends to 0 as n tends to plus infinity. Mn0 over n tends to 0 as n tends to plus infinity, since m and n0 are real numbers, plus epsilon over 2 tends to 0. So Sn is less than epsilon over 2. Therefore, limit Sn, n tends to plus infinity, is equal to 0. Another problem about sequences. Consider the two sequences UN and Vn defined by UN plus 1 equal PUN plus QVN over P plus Q. P and Q are two integers such that 0 less than Q less than P, and U0 less than V0 greater than 0. And Vn plus 1 is QUN plus PVN over P plus Q. UN plus 1 is given in terms of UN and Vn, and Vn plus 1 in terms of UN and Vn. First question, prove that the sequence Vn minus Un is a geometric sequence. 2. Prove that UN and Vn are adjacent. The two sequences are adjacent and determine their common limit. For the first question, Vn minus Un is a geometric sequence if Vn plus 1 minus Un plus 1 over Vn minus Un equal a constant R. We must find the ratio is constant.